talk about something that we call the lawnmower problem. We call it a lawnmower problem is when the ground is flat, so we're not on a ramp, but the force is at an angle. Did I say angle? Okay, so we are going to use components. We call it the lawnmower problem because when you're pushing a lawnmower, the handle looks like that. Now you could either, Madison, be pushing down, or you could be pulling up, or it could be on that side pushing down, or that side lifting up. But regardless, can you guess how we're going to start, Madison? Free body diagram, and we're going to go carefully with components. And this here, Alex, is where you're really going to have to be careful, because when we did our thought puzzle, we're a little casual with seeing how all the forces match. You're going to have your eyes move back and forth and see, okay, where are all the forces in the same direction? Because they won't be coming from the center of the free body diagram, but they will be somewhere on your diagram, Madison. We just got to spot them. So what's the definition? A problem where we have vertical force components other than normal force and weight. Say what? Here's the key idea. Normal force will not be mg. This here is why if last year you said friction is mu mg, I would have gone crazy and snapped, because I've always taught you friction is mu times the normal force. I don't know the normal force. Figure it out. I've never said mu mg, because here the normal force is not going to be mg. I like example 1. I like example 1. I like example 1 is a nice question. So it looks like what we're doing, we have some friction, not a big coefficient of friction. A mu of 0.1 you would find pretty slippery. Not ice, but let's see, it'd be like walking on mud, like the bottom of a mud puddle that can be kind of slippery. It'd be about like that. You'd have to watch your footing. And it looks like we're pushing down at an angle of 20 degrees, did I say? Angle, components, with 200 newtons. Alrighty, here we go. Yeah, Madison, I agree with you. This is a job for a free body diagram. No panic. We will walk through this. What are the forces? Get the obvious one. Yeah. And by the way, it was questions like this this is why last year I forced you all to go systematically. Because when I first started teaching this, Madison, kids always wanted to jump to this one. We'll get there. But let's deal with the easy stuff first so we can see how it fits together. So I totally agree. mg. The normal force here is not equal to mg, so I'm not going to do the normal force next. In fact, the reason I know it's not equal to mg, Madison, is we're partly pushing down. We're at an angle, but we are partly pushing down. When you push down on something, what happens to the normal force? Does it get bigger, smaller, or stay the same? Gets bigger. Okay, now I'm going to do components here. Because the ground is not tilted, parallel and perpendicular are not my best bet. My best bet is just like we did in projectiles, x and y. So I'm going to go d. There is fy and it's down. d. There is fx and it's to the right. And color. All right, Madison, what's next? Are we sinking to the ground like quicksand? Are we flying through there like Superman? So there is going to be a normal force. How big is the normal force? The normal force is canceling out that. What else is the normal force also canceling out? Can you see it? Fy. So the normal force, if I was being really fussy, Madison, would be the length of both of those added together. Here's what I know. It's bigger. So I'm going to draw it exaggeratedly so that I catch that it's bigger. I'm going to go, give me a second, yoink. Pause. So it catches my eye. I want to make sure I don't accidentally later on think, normal force is mg, right? Okay. Let's see. Is there an applied force in this question, Madison? There it is, but I'm not going to use the slanty one ever. The same as for projectiles with velocities. We never use the slanty one ever. I think I'm good here. I think that's my free body diagram. I think I've got, no. What am I missing? Friction, Madison, which way? Yeah, because I think the tug of war horizontally is between Fx and friction. So I'm going to draw friction in like that. Now, I gotta be honest, I'm making a guess there. Friction might be bigger than Fx. It might be small. It might be the same size. I don't know. But at least I got the direction correct. You okay with that? Good, good, good. Zaina, what does A want me to find? I don't know the normal force. And I can't really say, oh, but look. I know another force to say. Well, here's what I can say. Is it sinking into the ground like quicksand? Is it flying into the air like Superman? What that really means is that everything down has to equal everything up. Got to pause the video again. Sorry for my YouTubers, a little discontinuity here. Oh, and I didn't put an Fn on my normal force. I probably should have, yeah? Zaina, everything down equals everything up. What's everything down? Your hint is, look, there's two things. Yes. mg and Fy, or Fy and mg. That has to equal the normal force. Okay? I know mg. I don't know Fy. I'm going to draw the triangle over here a little bit larger just so I can see what's going on. So this is 200. This is Fy. This is Fx. And that's 20. Zaina, that 200 opposite. Oh, you're drawing. Sorry. I'll wait. By the way, I don't know if you remember at the beginning of the year, I said I hope you get as good at SOHCAHTOA trig as you did last year with formula manipulation. I hope you're at the boring stage for SOHCAHTOA trig, where when I'm asking you, what's that 200, you're almost mentally giving me an eye roll. Really? So what's the 200? Opposite of J? Yeah. And what about Fy? Which trig function? Are you saying Fy is sine again? I think as long as we draw our triangle like this, we should be okay with that. Okay. So you're telling me this is mg plus 200 sine theta. Well, let's put it in an angle. Sine 20. That equals the normal force. So we can use the same trick that we use during projectiles. It's a cheap hack, but it works. Now, if you're not sure, if you did the full trig, you would find sine 20 equals opposite over hypotenuse. Zaina, how would you move the 200 over? You would multiply. Sure enough, Fy is 200 sine 20. Okay, let's plug in our numbers. The normal force is going to be M 50, G 9.8 plus 200 sine 20. Zaina, what'd you get? $558.4. I'm going to, because I suspect I'm going to use this because friction is what times what, mu times the, I'm going to carry some extra sig figs and then I'll round off. So I'm going to go 558.404. And then I'll go equals 558 newtons. Yep. Lena, what's B want me to find? Friction is what times what? Ta-da! What did we find in part A? No, so what's mu? I don't know what's mu with you. It's going to be 0.1 times 558.404. I'm going to use my answer button. Actually, I can do that in my head because multiplying by 0.1, that's just going to move the decimal point over one spot, I think. I'll do it on my calculator just in case because I want this number stored. And I get 55.8. Okay, I got this. Alice, what does C want me to find? What does part C want me to find? Yeah, I know, you were zoning out. It's getting you back. By the way, if you want to guarantee that I call on you, you're kind of doing it, and I'll probably coming at you because I'm, bring you back, right? Always in love. What do they want me to find? So let's look at our diagram. Which way do we think this is accelerating? Then who's winning? And loud and proud, you're right. What? The most common mistake kids say, well, isn't the 200 winning? It's not to the right or up. It's a slanty one. We're not going to use the one that's at an angle. What's winning is the FX. Who's losing? Yeah. That's going to be MA. See it? FX minus friction equals MA. I don't know FX. Or, well, this is adjacent over hypotenuse. Can you figure out which trig function is going to be fx? Of course you can. Yeah, it's going to be cosine, isn't it? So we can go 200 cos 20 minus friction, which is, I'm going to write 55.8, but I'm going to use my answer button. Oh, how would I get the A by itself? So if you don't mind, I'm going to go A equals, and I'll divide by M right here. M was 50. There we go. Bracket 200 cos 20 minus answer button divided by 50. Now, if I get a, have I made a mistake? If I get a negative answer here, Mal, that just means that friction is winning. We're slowing down. I'd probably have to redo some of my equations. But if I get a positive answer, I'm probably pretty good here. I hope we get a positive answer. Hey, 2.64 meters per second squared. Yeah. You have a calculator issue? Okay. Today is calculator day. Let's do another one. Oh, here's one where we're pulling up instead of pushing down at an angle. And instead of pushing from the left, we're pulling up from the right. Okay. A force of 18 newtons, I'll probably put the 18 right there, is applied at a 21-degree angle to the mass below. Did I say angle? Components. Mu is 0.23. Find the acceleration. Do you want to try this one on your own, or do you want to walk through it? So I'll do it up here. I won't freeze my screen. If you get stuck, look up. Nick, how are we going to start? Don't let me down. How are we going to start? Darn right. Get the obvious one. Start with gravity, folks. Your hint is, I think the normal force is smaller because we're lifting up a little bit. Nick, is that okay? Can you see why the normal force is smaller? Fy is canceling out some of mg. Is that all right? Who's winning? mg? So we're sinking into the ground like quicksand? Which way do we think this is accelerating, kiddo? Who's winning? Good. Who's losing? Equals? Yep. Good. Lawnmower problems are tough enough. I don't take any shortcuts. I'm going to write every step because this is where I make more silly mistakes. So, hey Nick, which trig function is fx going to be? Rest of you keep working, but I'm just picking on Nick because I think he was kind of zoning out. Which trig function was fy? which trig function was Fy, what? So, which trig function is Fx? Yeah. Now, if you're not sure, hypotenuse, opposite, adjacent, A and H, cos. So, it's going to be 18 cos theta. I'll put the 21 in later. Minus, friction is what times what, Nick, my friend? That equals MA. Problem, I don't know the normal force. And this is tough enough, Nick. I'm going to do the normal force over here. So you ready? Are we sinking into the ground like quicksand? Are we flying into there like Superman? What that means is everything down has to equal everything. Look at my free body diagram. What forces are pointing down? Has to equal what forces are pointing up. Your hint is there's more than one. How would I get the normal force by itself? Uh-oh, I don't know Fy. What? Did you get that from Keegan, or did you actually remember that? Because I think I heard him whisper it. Okay, good. Now, Nick, one thing to note, look up. This whole thing is the normal force. So when I move it right to there, it's going to have to be in brackets. Because that whole thing. In other words, the 18 is going to drop down. The cos theta is going to drop down minus mu. And then in brackets, mg minus 18 sine theta, close bracket. That equals ma. Is that right? What was this question wanted me to find? So? I think you're right, but I couldn't hear you. Yeah. Is that all right? Okay. Sorry for picking on you, but it looked like you need a little bit of shake me to wake me kind of a deal. Let's carefully plug in numbers. 18 cos, what was theta? What was theta? 21 and 0.23 and 7. 18 cos 21 minus 0.23. 7 times 9.8 minus 18 sine 21. All divided by 7. Now, there's also the possibility friction might be big enough that it's winning. I'll know if I get a negative acceleration. Okay, bracket 18 cos 21 minus 0.23 bracket 7 times 9.8 minus 18 sine 21. Close off the close off the trig. Close off the mini bracket. Close off the top. Divided by 7. Boy, that's a lot of brackets. Let's see. 1 open, 2 open, 3 open, 4 open, and then 1 close, 2 close, 3 close, 4 close. Okay, my brackets match at least, I think. We get 0.359? No. There's a 5 next to the 8. We would round off properly. Now, if you, Quinn, calculated the normal force as a decimal and put it here, because I didn't round off at all, I would probably accept the 8 because your third sig fig might be off. But I would also say, why would you calculate it when you could have just typed it in once in the brackets and do it all in one step? But that's just me being me. 0.359. Yes? Mallory, that work okay? You lying? No? Okay. Sarah, you with me? You're not trying to organize other stuff? Okay. Now, one curveball I haven't thrown at you is, what if you have something like example 2 and we're pulling and nothing's moving? We're at rest. Well, actually, no, wait, Alex, if we're at rest, what can you tell me about the forces? They must be, I'm looking for a word that starts with the letter B. That gives you some options, because that means instead of winner minus loser equations, you could say, oh, I know these two forces are equal to each other, or these forces are equal to each other, which lets you take some shortcuts. I think there's one like that on the homework. What's your homework? Number 1 is good. Number 2 is good. Three and 4 and 5 are cool, but I'm going to skip them in the interest of time here. 7 is good. $11 is good. Let's go 12, 15, and 16. Oh, here's one where it's not moving. Okay. You can also do any question you want on the ultimate vector dynamics review.